Okay, this is another question. Determine the force in each member of the truss. State if the members are in tension or compression. Let's look at the truss. So is this difficult? No, it's the same thing. But remember, here there is a hinge at F, and there is also another ruler here at E. So there is one reaction here in the y-axis, and there is two reactions here, one in the x and one in the y. But do we have to find the reaction F and E? What? No, I don't think so. Because here, what did he want? He wanted to determine if the force in each member of the truss. He need to know the forces in the truss. This force here, AB, force AC, force BC, CD, DF, EF, and CE. He doesn't want the reaction of these. Sometimes you don't have to find the reaction of the hinge and the ruler to answer the problem. So to solve this, let's start from joint A. So this is, we're gonna do the joint method. Let's start with joint A. So joint A, let's look at this joint A. There is a force here, 130 pound, 130 pound. Remember that this is the slope of this force, 12, 5, and 13, 12, 5, and 13. And there's a joint A, there is a force AB. Let's call it force AB, FAB. And there's another force AC. Assuming it is tension or compression, you could assume it initially all tension, and if the answer was negative, then you switch it back to compression. Or you could assume it compression, and if the answer was negative, so you could change it to tension. But here in the solution of this book, he assumed this one tension and he assumed this one compression, because I think he knows the answer. That should be positive at the end. But you're not supposed to assume things, compression and tension, just like this. Assume them all tension, and then check. From what he give this the slope of this force, well, you can see here, this force AC, 3 in this side in the x-axis, so you put 3. And you can see this one, 4 in this side in the y-axis, he put 4. 3 square plus 4 square, all under the square, you'll get 5. So 3, 4, it should give you 5. So how could you analyze this? So you go and make, in the joint method, there is no summation of moment. There is only summation of forces in the x and summation of forces in the y. So let's find summation of forces at the x. Okay, or here he just did find summation of forces at the y. Summation of forces at the x and summation of forces at the y, you can do it with this equation. Let's do summation of forces at the y, of course, because here in the y, you have, this is one unknown, but in the y, this and this, so you could find FAC. So you could find the force FAC, okay? But if you want to do in the x, you'll have two unknowns in one equation. So we'll start with the summation of force of the y, so you could solve FAC, because as summation of force of the y, you have only one unknown, FAC, and this is not going to be considered in summation of force in the y. Okay, so let's find summation of force of the y. Remember this one, FAC, 4 over 5 in the positive y, minus 130, because this is going to go negative y, 12 over 13. So 4 over 5 FAC minus 12 over 13, 130, because he gave you the force 130. 130 is here. So now the force FAC, and it gave you a positive. That's why he made it compression, because he don't want to switch from tension to compression. So it's positive, it's compression, and he assumed it initially compression. You don't have to assume tension, compression, and play around. Assume it either all forces tension, and then if it's negative, change it to compression, or assume all forces compression, and if it's negative, make it tension. Okay, so now we know FAC. Now let's find FAB. Now we know this force, we know this force. Now we could find summation force of x and find FAB. So summation force of x, FAB minus 3 over 5, 150. Remember 150? Now FAC is 150, so FAC 150, and now it is going, see, it has like this and like this, positive y and negative x. So 3 over 5 minus FAC. So minus FAC, which is 150 times 3 over 5. And the last one, in the x, remember there's negative y and negative x. 5 over 13 minus 130. So we do this, we could find FAB as, now the answer is positive and it's tension, so we make it tension. Now we found the joint A, so this is the answer for joint A. Let's find the next joint. What is the next joint you want? There is an easy joint here, joint B, because joint B has force FBD, FBA, and FBC. So like this, FBD, FBC, and this force 140. Now this is very easy. You could find summation of force at the X. Now we know this one because we found if this one, the force AB, we found the force AB, and the force AB, it was 140. So we could make this one 140, and it is, of course, here is tension, so you could keep it here tension if you want to. You are pulling. If you do summation of force at the X, FBD minus 140 equal to 0, which means that FBD is equal to 140. Okay? So FBD minus 140 is equal to 0, which means that FBD is 140 tension. Now, summation of force at the Y, how could you do it? There's only one unknown, FBC, and there's nothing else in the Y-axis except that, which means that FBC is equal to 0. So summation force at the Y equal to 0, FBC is equal to 0. Sometimes, only by look, you can see that at look, joint B, you can see it here and here and here. So which means that this one will have no loading on it. This is like nothing, there's no force. You don't have to make it very strong. So this bar, you don't have to make it very strong in a way that it will sustain a lot of loading. You know that there will be not much loading on it, so you don't need to have a lot of steel, a lot of concrete here to sustain the loading on top. So BC is 0. Now, let's look for the next joint. Joint C. Joint C, you can see joint C is here. So we started A, B, C. So we have to do it like one after each other because we want to know the forces. So joint C, remember, CE, CD, CB, CA. CB, remember, is 0. Look, we just found it. CB is 0. So we have CA, and we found CA. Remember CA? 150 pound, and it's compression. So we should make it compression on C. This is 0. CD, make it tension, and CE, make it tension. So we have two unknowns and two equations. We could solve it. So let's go to joint C. So like this, remember, compression 150, FCD, assume it tension, and this one he assumed it compression. I know he knows that this is going to be positive. You could assume it tension and it will give you a negative later on. Remember that the slope here, 4, 3, and 5. It is, you can see it, this is 3 in the X and 4 in the Y. So this is 4 and 3, and 4 square plus 3 square, or under the square, it will give you 5. Here you could find the same thing for joint C, summation force at the Y. There is one unknown. So you could find summation force at the Y equal to 0. You'll get FCD, it's plus, so assume tension, so it's tension. And also summation force at the X, we have FCD this time, and we could find FCE. So we could do summation force at the X equal to 0, so you'll end up with one unknown. FCE is 180 pound, and we assume it's compression, and it's positive here. I know he knows that this is a compression, so he made it like easy on him. So FCE is found 180 pound compression. Now, let's go for the next one. We went to joint A, joint B, joint C. Now, it's not good to joint E. Do you know why? Because you have to find the reaction of the ruler. So let's go for here. Let's go for joint D, because I want to be away from finding the reaction Fx, Fy, and EY here. So this is good of the solution manual that he did not go to E, because in E you have to find EY, the reaction of this ruler in the y-axis. So he skipped from C to D. So D, you have DB, and we have it before. You have DF, we will find it. DE and DC, and we find DC. Okay, so let's go for joint D. Joint D, what is joint D? Joint D is here. You have 140 pound tension, DF to the, this is the negative, it's tension, and this is positive. I'm assuming tension, and this we found before 150 pound, 3, 4, and 5. And FDE, he assumed it compression, and you know it's he knows the answer, so he assumed it compression. You can assume it tension and then later on change it. So joint D. Now, what to start? Summation force at the X or summation force at the Y? Let's see. So I think the best, you could either way, because you can see that the unknowns are in the Y-axis and one in the X-axis. So whatever. Let's start with summation force at the Y. Summation force at the Y, you could find FDE going plus minus 154 over 5. That's it. So you could find FDE compression, 120 pound is plus, and our assumption was compression here. Sorry. Summation force at the X, we have FDF going positive, minus 140, minus 150, 3 over 5. So this is FDF is 230 tension. Now, we found all these forces. What is next? What is next? Now, the next is to find E. Okay, since F will have 2 reactions and E will have only 1 reaction. So let's look for E. You're going to end up with finding EY, but there is no need for EY. It's better than just going here and finding FX and FY. Let's go to joint E. Joint E, you'll have EY unknown, you'll have 180 pound from the previous one, and you have 120 pound compression from the previous one, and you'll have EF. So this is, here we have 2 unknowns. We have EY, and again, he doesn't need EY. He only need EF. So the best is to find what? To go summation of force at the X. Because, wow, he doesn't need EY. You don't have to find EY. So summation of force at the X is equal 180 plus minus EF 3 over 5. So 180 minus 3 over 5 EF, force EF, you'll get, and he assumed it here, compression. So he made it like this, S plus, so it's compression 300 pounds. See, this is, will conclude this problem. Again, since he did not ask to find the reactions, so there is no need to find EY. Okay?